So I think we'll start from here. But first of all, I have to apologize. Because when we prepared this panel talk, we came to the conclusion that we're all a bit uncertain about agentic AI. But nevertheless, we're going to talk about it. Because we're confident that we're not knowing what it is about. So we are trying to learn from you as an audience. Nevertheless, first of all, to kick off, my name is Arno. I'm the Managing Director of Unica Data Centers, working at the intersection of design, build, maintain data centers as a service provider, as a contractor. And I've been working in this industry for over a decade. But I think at this moment, things are moving so fast in such a challenging geographical area that one thing that really struck me over the last weeks, I think you all have heard about the World Economic Forum in Davos. And that was where ARM CEO, Mr. René Haas, openly stated, and you can look it up at one of the YouTube movies, centralized AI compute is hitting hard physical limits. So energy, cooling, and memory bandwidth need a shift towards a more distributed intelligence, meaning not only running large language models and training AI in big AI hyperscalers, but also pushing agentic AI, so self-decision-making, autonomous AI, closer to the users, and for that reason, running more inference at farther away from basically the main hubs, as we see in the FLAP-D at the moment. So said that, today we will explore why decentralized compute is essential for the next step in AI, which they call agentic AI. And I'm very pleased to introduce my experts, I would say industry dinosaurs, but that would be a bit rude. Mr. Harro Beusker, CEO of Enlighten, Mr. Bob Sprenger, CEO of Penta Infra, and Mr. Peter Mudd, working for ServiceNow as a Senior Director. So please welcome us on stage. So that means sometimes I have to look at my paper just to follow what we're talking about, because as said, the topic is quite challenging. But I think we have developers, operators, as well as SaaS users here on stage. So we should be able to make something worthwhile to watch for the upcoming 30 minutes. And thank you for joining us. But first of all, let's start. Harro, can you please introduce yourself and your company which you're representing?
So my name is Harro Beusker. I'm CEO of Enlighten. Enlighten is a distributed compute platform, data centers. We have 34 data centers across Europe in 7 countries. In this we're very much into, well, agentic AI, maybe not yet because that's really new, but into inference. We focus on inference in AI, so using AI as a user. And if you allow me to say a little bit about agentic AI, because it was actually on TV, national TV yesterday evening here in the Netherlands. A tech expert, Alexander Klupping, showed a new Google app and tool which is agentic AI. And what was that? That is that you can not only, in every AI tool this moment, every LLM gives you, if you say, I want to go to an Indonesian restaurant in the area of Amsterdam tomorrow evening at 7 o'clock with 2 people, then you get an answer. You probably get 5, 6, 7 choices. Agentic AI can then actually make the reservation. So you can ask the AI, okay, I want to go to that restaurant, can you make the reservation? What the AI then does is it goes into the browser of that restaurant, it works out how that works, and makes the reservation and gets back to you. There was one thing that happened after that in that TV, which shows the real strength of agentic AI and generative AI, is Alexander said, I asked myself, if there is no reservation system in the internet, what does the AI do then? And he set up a fake restaurant, and he asked the AI, so the AI came back and said, I cannot make a reservation because there is no reservation system. And Alexander asked, figure it out. And then the AI thought about, okay, there's his phone number. So the AI made a program to fake the voice of Alexander, and called that number and said, I would like to make, I'm the AI assistant of Alexander Klupping, I would like to make a reservation for 2 people at 7 o'clock tomorrow night. And he answered that phone himself in the live TV. And he said, I'm very sorry, sir, but we don't have spaces. Which then the AI responded and said, are you absolutely sure? Because this guy is very famous in the Netherlands. You want him as a customer. And he said, no, sorry. So he answered himself again, live. So the AI assistant talking to himself said, no, really, we don't have space. Is there no space at the bar? Can you not have 2 seats in the bar? I said, no, sorry, we cannot do that. Are you absolutely sure? Is there no way to do this? Can you not go later or earlier? No. And only after the 3rd time, the AI gave up and said, okay, I understand. That's a little bit freaky, but that's the strength of AI. When agentic AI is when machines start to talk to machines. Then, of course, you can imagine what happens. Then the data traffic will explode, the usage will explode. And that's what agentic AI is. Yeah. And that's what inference to the power of 2 or the power of 3 will be. Yeah.
That sounds a little bit like The Matrix. I'm born in the 70s, and then we saw the Matrix movie, I think it was late 90s or so, but this sounds like it's coming to stage. But thanks for your introduction. Mr. Bob Sprengers, Penta Infra, can you please introduce yourself?
Yes, good afternoon. Bob Sprengers, CEO of Penta Infra. Penta Infra is a European edge operator. We currently operate in 15 locations in 5 countries, Netherlands, Belgium, France, Germany, and Denmark. But we have big ambitions and we want to grow fast. And to do so, luckily, we have 2 great investors, Photon Capital and PGGM. And together with them, we try to develop as fast as possible, always European-focused, colo player, but also making sure that we're ready for this whole new AI wave and make sure that we do it in the most sustainable way possible.
Thank you. And then we have Peter. Peter, welcome as well. Can you please introduce yourself and your company as well?
Yeah, hi. It's working? Hi, Peter Mudd. I head up data center operations globally for ServiceNow. Been with the company 13 years, so seen a lot of expansion. My team run the data centers, so we do use co-locations, but my team are the people on the ground operating the data centers. We're in 14 countries globally, and our topology of data centers is that we will have 2 peering data centers in country, so they'll actually mirror image each other. So a customer's instance, primary instance, could be in either location. That gives us the opportunity to do AHA, which is advanced high availability. So were there to be a problem in any of those data centers, we could move a customer to the peering data center and they could carry on as normal. Just on the AI stuff, obviously, it's a lot of buzzwords around AI, but the big thing for us is localizing GPU footprint, and I think we're going to talk about that. But yeah, a lot of the footprint, high density, how you call the GPUs is, a lot of it is across the globe. We, mostly in America, they'll have sites that are structured for GPUs. But now customers want not just their data to be local, but their large language models, they want them to be in country or in region, if possible.
And adding to that, a big Arsenal fan, as I learned, so you had a good night last night.
Yes, I did, yeah, so it's all good.
Yeah, you just touched base upon, basically, if you go from LLMs to more agentic AI, Haro, maybe to you, when it comes from operational and geographical view, what's your opinion on how do you operate agentic AI applications in your data centers, and is geography going to be an issue?
I think it is. And of course you can operate agentic AI from the current DFLAP locations. You can. So it's not central against decentral. But it is very logical that it's going to be more decentralized, because you want to have that agentic AI, or in any case, in general, inference using AI that's driven by the user. All of us here in the room, this thing is going to create demand for inference, but also a lot of laptop computers, etc., and industrial usage. So the data traffic alone, it's not just low latency, yeah? So low latency is a factor, but I think that the main factor is the data traffic. Another example, just to make it alive, Automated driving, that is at the horizon. Automated driving needs to happen in the car because you cannot risk network failures. The car cannot be dependent on the network. But the traffic optimization in a city is definitely going to be very beneficial if you organize that. A car generates up to 40 terabyte in data per hour. You cannot carry that traffic from the whole of Germany into Frankfurt or from the whole of the UK into London. That is physically impossible. So you need to bring that in a region, and you do that in München, you do that in Stuttgart, you do that in Berlin, you do it in Manchester, you do it in Liverpool. So you drive out that traffic volume that goes to a data center and out again to the car. And of course, the latency helps. If it's a couple of milliseconds, it's better than if it's 50 or 25 milliseconds. But the main thing is data traffic and just the compute that you need. The compute is going to be enormous. When computers start to talk to computers, then the data, and that's what we just talked about, and that is what this will be, automated driving as well. And this is just an example, yeah? There are thousands of examples that you can give, but that's why data and compute will be driven more into the region, into distributed infrastructure.
And then to you, Bob, do you already see this as part of your geographical position when it comes to site selection? Do you already see that we need more tier 2 and tier 3 locations? How are you looking at it?
Yes, I do. Is this working?
Yeah.
Yeah. And you were saying dinosaurs. I'm in industry for 2 years, and 2 years ago I was here for the first time, and there was a lot of no, it's not too bad. There was a lot of AI talks, and which was quite interesting, but it didn't say much to me. But I had the feeling it didn't say anything to anybody. But a lot has changed, right? So now we see it going from talking about it really to implementing it, and really we do see customers coming in. And if you talk about, let's say Sophia. It's the most powerful Belgian supercomputer that we recently housed into our Brussels facility. So that's an extremely important customer that is bringing high density. Luckily, we developed this specifically for these kind of high-density AI customers. So I had all the heating and the cooling and also the heat reuse and using rainwater to cool it down, etc. It's all installed like it. But we also see more and more 800 kilo plus enterprise companies coming to us and really going from a pilot phase, really going to signing contracts and really putting it into our facilities. So yes, it becomes really important to be in the right locations, and that is on the edge locations. And talking about, you were saying about a latency small factor, I do agree on the amount of capacity that you need, amount of data, but latency is outside of operational resilience. Latency is very important. If you talk about stock trading, medical imagery testing, if you talk about quality control in production plants, you want to be close and you want to make sure that you have it fast and you have the right quality there.
And does it give a change in the service level agreements that customers running such applications differ from, let's say, more 5 to 10 kilowatt rack application clients? Is there a new KPI in such SLAs when it comes to AI or agentic AI loads?
No, I'm not sure if it differs. It's a different way of working. You have to make sure that you can deliver it in such high capacity and such high densities. But in the end, the SLA doesn't change so much, I think.
Okay. And Peter, do you already have some AI applications running in facilities like these gentlemen operate? And what's your selection to a site, to use which site, to put your software running in a certain situation?
So we go through sales pipeline, but we can all know sales can be very optimistic with their figures sometimes. So we look at, new geos, new kind of countries. We are seeing not sovereign, but more perception customers want to stay in country, government customers. So we've kind of explored that. We work with the public cloud as well. We know we should be available in all the clouds, so our customers. But yeah, and then we can wrap that round, with the AI, using of AI, because we've got the CMDB, which is the main thing for a company is their CMDB for a technical point of view. And that's key because the data in that has to be accurate. That's how you start, with an accurate CMDB. When that is accurate, you can then overlay, the AI. You can kind of look at knowledge base articles. You could be informed then when you go to do a break fix for a customer, but you can use AI on top. And we've got obviously workflows. We've got a great platform that actually can integrate with other platforms. So the front office can actually mix with the middle office, the back office, but it's all done seamlessly on one pane of glass.
Okay. Getting back to you, Harold, because when we had our preparation meetings, I was quite impressed. And we can't sign NDAs with all of the audience, so I understand you can be truly open about it, or fully open about it is the right word. But I understand you already have customers running on liquid-cooled racks, maybe even suites. So how are you adapting? How are you preparing your facilities to questions that are a bit maybe unknown yet? Or how do you look at it? How are you preparing for this next step in AI?
Well, we put a lot of effort into trying to get to know this world as quickly as possible. We installed our first large installation in November 2024 in one of our UK facilities. That was a large NVIDIA H200 installation of 3 megawatt, and that works with rear door cooling. So that is, in essence, air cooled, but you push the water to a rear door, and then you have a heat exchanger, and the cold water is exchanged into cold air pushed around in the rack. So that's the essence of rear door cooling. And with that, you can go up to 50, 60 kilowatt. We don't have 60 kilowatt installations, but we have up to 50 kilowatt with rear door cooling. And that is the H100 and the H200 generation of NVIDIA. We have a couple of those installations across our portfolio, mainly in the UK, but also a little bit in France, some in France. And we recently installed in Germany, and I'm not going to say the data center, so it's reasonably okay with regards to NDA. We have the first installation with Blackwells. We delivered that in November last year, and that's a 400 kilowatt, and that is DLC, that's direct liquid to chip. Very interesting from a technology point of view. Has its own challenges. You need to be really on top of that. But it's a very cool technology. The only thing is that what is important to know, we are in the beginning, yeah? We are in the beginning of this industry. This DLC implementation is fantastic, that we have that and that it runs. But just something to note is that direct liquid to chip, you also need at the background air-cooled background. So you need to have as a backup up to, let's say, 10 kilowatt, 15 kilowatt per rack of the 60 kilowatt that it is running. This is 60 kilowatt per rack DLC. You also need backup air-cooled because the technology is not yet perfect. And that will be, I think, still for a couple of years the case. NVIDIA is working on this, but those are the things that you need to keep in mind with these installations. But it's very interesting, and we really invest time and money to understand it so that we can deliver it to customers. Yeah. And it's a change in the data center industry. It's the next step. Yeah, the hyperscale revolution was great for scaling up our industry. But it also became a little bit cookie cutter. Yeah, you build the Amazon design, the Microsoft design, the Google design. Very interesting, but cookie cutter, very capex intensive. It still is, by the way. But now it's becoming more technology focused, and data centers are moving a little bit more into the technology frame, which is really interesting. Yeah.
And then I learned that as well as your customers, you can also own the GPU. So you basically put in all systems, including...
No, we don't own GPUs. That's the Neo Cloud. That's not what we do. We stay to be a data center. Yeah. We own the CDUs, so to do the whole thing with
the cooling.
The CDUs. Yeah, we do the whole CDUs for the thing where you basically switch between cold water and cold air and managing how that works. That is what we do. That is what we consider to be the data center infrastructure, but not the GPUs and not the micro. Strategy and all the other, not the servers, etc. That is what the customer stays to do. So we do the same as before. That's what Bob says. We do the same as before. Okay. It's just a little bit more complicated. Yeah. And I do agree, by the way, that latency is still important. Yeah. So yeah. Don't get me wrong.
And then I was a bit shocked at understanding that you get questions from clients that say, "Okay, Harold, we like your facility. We want to be up and running in 6 months." So you need to be not only implement something new, you also have to implement it really fast.
Yes, and that's another aspect of this industry. It's very fast. That has to do with the renewal cycle of the NVIDIA chips, especially NVIDIA, but this whole industry is going very fast. So the cycle is 2 years. That means that, and these chips are getting factor 2, 3, 5, NVIDIA claims 10, but even if it's only 2 to 3 times as fast, the economics change. And it's not just the economics of the cost of the chip, but also the energy usage. So if you can run a new generation chip after 2 years, and it's 3 times as efficient, then it's also 3 times as less power consumption. So that's economically extremely important, but also very threatening. So when you are a user, a corporate or a neocloud, and you buy a chip, then you want to deploy that as quickly as possible. So when people, especially the neoclouds, when they have bought the chips and they will be delivered in 6 months, then they also want to deploy them right away. So that's the challenge for the data center industry. We need to be ready to do that in 6 to 9 months. Yeah, 6 months, yes, 9 months, most of the time is okay. 15 months is a big economic problem. Yeah. So that's another challenge, yeah, that we need to face.
Do you agree with that? Do you see the same?
No, I fully agree, and I think it has been pretty static in the past decade. I mean, we need to be really flexible right now, which is a big change. And flexible for what? Do we actually know what is coming? Do we know how it's going to change? So really making sure, we try to make sure that we're as flexible as possible, having the air liquid and everything working together, having 40% AI ready, but also making sure if demand's getting higher that we can quickly change out the rest as well. But if you talk about the customers and the quick implementation, I do also think that what I see is that, yes, they want to, and they want capacity ASAP. On the other hand, when we make it available, and we can make it available, they also have problems with delivery times on the products that they need. So then often it even takes longer than expected.
Yeah, unfortunately, yeah. And Peter, from a historical point of view, because you as ServiceNow are based globally in multiple sites, what was past tense your arguments for site selection, and have they changed, or will they change if you see agentic AI coming in?
No, I think it's the demands is always going to be the driving factor. We're seeing, with going back to the GPUs, and the guys are right, I think technology is going very quick. I worked at Credit Suisse years ago, and we ran fiber optic to the trader's desk because we thought, they're going to need this bandwidth and all that. Do you think we ever used that fiber? So you've got to be very careful, and I think there's this kind of, not misconception, that's probably wrong, but this hesitancy to go into liquid to the chip. Because if you've got GPU, that's great. But unless the other manufacturers out there get to chip, you could have a GPU rack that's 100 kilowatts. The next rack's 20 kilowatts. What are you gaining? You know, if I go to my data center operators and I say I'm going to have 2 megawatt, they give me a football pitch. You know, so you kind of, what we're seeing with the customers is that they want GPU. We did regionalized GPU. So originally we did Canada for the Americas, we did Japan for APJ, and then we did Germany for EU. But then we still saw that customers wanted it more local. So we've kind of gone smaller on our nodes, if you like, globally, but we've gone localized. And we've also done a POP solution. So what we've done with the network, we've dragged the network away from the edge. So now we're going to have 20 POPs globally, and we're going to have CMDs. It's going to be CMVs. Sorry, they're going to be customer mobility zones, where a customer can move anywhere within that region, and they keep their IP address because the IP address is at the POP. So it's complete segregation from the network to the capacity site. And the capacity sites then can be in areas that are greener, you know, more affordable, rather than being, you know, telco-rich, high-end kind of facilities which cost more revenue.
Good, but touching base upon that, I learned that LLMs are sometimes ruining PUE because they have the peak energy points, and then there's a long time nothing, and then it hits again. And you said something strange, that you're sort of trying to manage the compute load. Can you elaborate a little bit?
Yeah, well, the guys probably can speak a bit around this as well. So the problem with, training large language models, you will get a high compute for a short period of time, and anyone that knows mechanics and electrics knows that, it doesn't like spikes. Yeah. So they're trying to look at it and maybe do dummy loads or something like that can keep the kind of consistent kind of power usage, because the problem is with the mechanical and electrical that usually lasts 10 years will be needed to be swapped out in 2 to 3 years. So there is something that we need to look at there. And then the noise. I don't think people understand the noise you can have of these GPUs. If you try and do a superpod, it's like an airplane taking off, and the decibels aren't workable. So we need to look at that from a health and safety point of view as well.
Oh yeah, interesting. I haven't thought of that as well. But as I understand, we see upcoming that we have large facilities, hyperscalers running those training models, and we see, as you clearly indicate, pushing the more agentic, more self-autonomous AI to the edges, to more geographical, decentralized locations. Our previous, the people that were on the stage before, they said, okay, we're going to harvest heat, which has been in the industry, I think, for the last decade. And I wouldn't necessarily say very successful, because we try to harvest heat, but it is only there at a small scale. This push out to more decentralized locations will give new opportunities to become more greener, as you just said, because you're closer actually to, let's say, environments that can incorporate data centers as well. So is this a point in site selection as well, or am I just dreaming, because I learned this morning that I should dream? So maybe am I dreaming here, and I'm dreaming enough?
No, you're not dreaming. This is what we need to do. This is unavoidable. We cannot keep pushing the heat out, and on top of that, using water to create cold. Yeah, that's the standard in the large data centers at this moment. You evaporate cold water, or you evaporate water, yeah, to create heat, and then you push the heat out as steam. So that's double bad. There are ways to not use water to create cold. You can do it without water. You only use water as a medium for your system. And the other one is that you can exchange heat, but you need to be in the right location for that. One of the issues in the Netherlands, for instance, was there was this data center of Meta that was planned for Zeewolde with all good intentions. But one of the statements was, we will reuse the heat generated in that data center to warm houses and offices. And that turned out to be not possible, because Zeewolde is in the middle of Flevoland, in the middle of the countryside. The data center was going to be 100 to 150 megawatts. You cannot bring 150 megawatts of heat load to bring that in Zeewolde. You have to bring it to Amsterdam, and the moment that water is in Amsterdam, it's cold. So that doesn't work. But where you can do it is you can in Zeewolde do 3 megawatts of heat load exchange. You can do in Amsterdam, within a circle of 5 kilometers, you can go up to, let's say, 15, 20 megawatts. And that is the size of regionalized inference-focused data centers. So you can do it, but it's something that we call that coupled in Enlighten. You couple the data center with the energy infrastructure in your environment, and there are fantastic opportunities to do that. Yeah, it also saves money. Yeah, it's also an economic point, but it is especially for our credibility towards the community, towards the world. It is something that we definitely need to do.
Rob, yeah.
No, I do fully agree, and site selection is important by doing that, and Edge will help a lot with the smaller, not the big, huge hyperscale data centers. You're also talking about PU levels. I do think if you put this high-density AI customers in old facilities, it's extremely difficult to get to those low PU levels. If you develop it from scratch in such a way, looking at the heat reuse, looking at everything, and actually it's not even theoretical anymore. We all have customers that are running up to the high densities, and they do deliver under 1.2 PUE if you develop it from scratch by really integrating it in the full campus, in the full neighborhood, in the full environment, yes.
Just checking in with the audience, we've got like 5 minutes left. If there's any questions or anybody wants to make a statement because we're wrong, because we don't know either, just shout out. It's a bit hard for me to see, but is there any questions from the audience? Just let us know, and otherwise I've got a couple of pages of questions as well. So I'm going through a steep learning curve here on stage. No questions, so we continue. If you look ahead, this is towards you, Peter. If you look ahead and you take a look at what Haro is doing with Enlighten, what Bob's doing with Penta, would that be a good fit for you as a SaaS company? Is this exactly what you're looking for, or what's going on in your company when you look at the market that's developing?
No, so our product's got to be flexible enough to go in and out of every cloud, as I said earlier. And we're always looking to partner with the best provider that makes sense in that location. So, we're not kind of just tied to any one location or, colo provider. So yeah, it's very interesting. I'm very curious as well to see what their roadmap is with green energy, because I think it should be front and center. We talk about PUE. I like to see CUE, which is carbon usage efficiency, come to the floor, because these renewables, they say, oh, we're 100% renewable, but it really is papering over, because they say they plant 1,000 trees in the rainforest, and that goes towards their renewable global footprint. And I would like to see providers, local authorities, cloud users get together and work out how we can build greener grids. Because unless we do that, and that's where I think liquid will have to come in, because it is the most efficient. But we need to invest, and we need everyone to come together to actually try and solve this problem.
Yeah, you already mentioned local authorities. They're a very important player in this whole thing, because I think we all want to do as good as possible. But you need the possibility to get rid of the heat. You need, we have examples where we can integrate the generators, where we can help the electricity network, etc. We can do a lot of things. We want to do a lot of things, but yeah, you have to work together with all three parties. Yeah.
And then Peter, I'm trying to. Oh, you want to comment on that? How?
Yeah. What we call that CFE score, and that's indeed focused on carbon neutrality. How far can you get? And that is taking all these things together. So, and it's not on the basis of planting a forest in Africa, but it's on the. I fully agree with you.
Sorry.
That's nice, but it's not really. Yeah, it's helping, but it's not really what you want. You want to know, when is the energy generated? Is it a renewable source or not? Then you get to a certain percentage. If you purchase your energy with that in mind, you can get to 70%. And then on top of that, you have these things with heat reuse. We call it grid stabilization, where you offer your generators to the grid, so that you can generate energy when the sun is not shining and the wind is not blowing. And then you can get up to. We not really got to 100% yet, yeah, but we got to 85, to 90%, to 92%. Depends a little bit. In Spain, you can get very high, because there the wind and the sun actually can help you to get to 80% or something, or 75%. But there are ways to do this, yeah, especially if you're linked into the local energy infrastructure. And I think it's not as popular this moment as it was 3-4 years ago, but I'm pretty sure it will come back, and it's crucial for the future. Absolutely.
Yeah. So this might mean, if I look at this and you go out of the FLAP-D or the upcoming tier 1 markets, you might debate that when you go to urban planning, you might want a smaller size data center, 5 to 10 max, in each suburb. Basically be part of the solution, latency, agentic AI, heat reuse, but also net balancing. We see the first projects, at least for me here in Holland, coming to market, where as well as backup power, the backup facility serves at peak shaving, in the grid, basically. So these guys are then all planning 5 kilowatts per rack, 10, 20, and then you come in, give me 200. What's your expectation?
No, I'd say you've got to be able to cater for all, really. That's what we're looking at. Yeah, I know, yeah. But it's...
Haro's ready.
Yeah, no, we grow organically. We've grown to quite a size, but we leverage, as I said earlier, the public cloud. I think we've got to be available, but and we're nearly on time here. I think one of the challenges we've got as a data center organization industry is talent, skill set. I'm glad to see there's women in the audience here, because it's a lot of middle-aged men. And we need
Thank you.
And the data center demand is going through the roof, and we just don't have. We've got to find a way to get early in career talent into and diversity into our industry.
So just I think we're about to wrap it up. What I learned on this stage is that basically on one end you have the big facilities doing the large language models. We see on the horizon or already coming up, as Harald explained, Agentic already being there. I mean, Agentic AI coming to the edge. And basically, what I also learned is that Agentic AI isn't waiting for the perfect infrastructure, for the perfect facility. So on one end, we have the facilities. You guys keep on developing new facilities. And on the other hand, we see it coming to market maybe really fast. So yeah, you can't plan for it. We have to sort of adopt it. And I think that's basically the message for today. It's coming. We're not sure how it's going to look like, where it's going to land. It will be spread out throughout basically, the globe, maybe even. And yeah, we have to be ready for it. And I think you guys are doing a good job to give Peter some room to do his thing. So thank you.
I will tour your sites.
Yeah. Thank you for us. If there's anything from the audience, shout out. Otherwise, I think we go have a cup of coffee. And thank you for your attention. Thank you.